Alright, let's look at practice exam 2, problem number 8. Alright, so we have this function f of x comma y, and we want to find its critical point. Alright, so let's do that. Alright, so we take the partial derivative of f with respect to x, alright, which is going to be 2x and plus 6y. And a partial of these guys are 0 because these are constants. So we set this guy equal to 0. Right? Then we partial of f with respect to y. Right? So that's 0. That's 6x. And plus 20y minus 4. And partial of 4 is 0. It's a constant, so this is equal to 0. Alright, so we got that. Then what we want to do is maybe we want to multiply the top equation by, say, 3. Multiply this guy by 3. So we get 6x plus 18y is equal to 0. Right? Then we can let's see. I'm gonna just actually copy exactly the same thing, or we can actually multiply by -1 if we want. Right? So that would be negative 6x minus 20y plus 4 is equal to 0. Right? Then what we can do is add them up. Right? So 6x plus negative 6x cancel out. That's what we wanted. And 18y plus negative 20y would be negative 2y. And 0 plus 4 is 4. And 0 plus 0 is 0. Right? So from here we can solve for, so let's say subtract 4, negative 2y is equal to negative 4. Then we can divide through by negative 2. So you can see that the y is equal to 2. Right? So once you know that the y equals to 2, we can probably plug that guy into, so whichever the easiest equation, I will plug this guy into here. Right? So you will get 2x, right? And 6 times 2 would be 12, right, is equal to 0. So subtract 12 from both sides, you get the 2x is equal to negative 12, right? Then just divide through by 2 to get the x value to be negative 6, right? So therefore, the critical point, right, critical point is x equals negative 6 and y equals 2. Right? So that's part A. Part B, we're going to use second partial test to determine the critical point, yields relative max, relative min, or saddle point. Right? Let's do that. So we need to find the second partial with respect to x, which is equal to, with derivative of that with respect to x partial, so it's going to be just 2. Right? And then we look at the second partial with respect to y, which is going to be second partial with respect to y, so that's 20. Right? Then mixed partial xy is going to be, so partial of this guy with respect to y, so that's 6. Right, so if you look at the quantity, say d, is equal to, let's see, so 2 times 20 minus 6 squared. So that's 40 minus 36, that would be 4. Right, so 4 is positive. This tells you that it's going to be a bowl shape, so either facing down or facing up. But since the f double prime, f second partial with respect to x is 2, which is positive, which means that it's a facing up a bowl. So which means that this is going to give you a relative minimum, right? So a relative minimum at the critical point, -6, 2. All right, that's it. I hope that this was clear.